In mathematics, the polylogarithm is a special function Lie, z, of order s and argument z. Only for special values of s does the polylogarithm reduce to an elementary function such as the natural logarithm or rational functions. In quantum statistics, the polylogarithm function appears as the closed form of integrals of the Fermi-Dirac distribution and the Bose-Einstein distribution, and is also known as the Fermi-Dirac integral or the Bose-Einstein integral. In quantum electrodynamics, polylogarithms of positive integer order arise in the calculation of processes represented by higher-order Feynman diagrams. The polylogarithm function is equivalent to the Hurwitz zeta function a either function can be expressed in terms of the other a and both functions are special cases of the Lerch transcendent. Polylogarithms should not be confused with polylogarithmic functions nor with the offset logarithmic integral which has a similar notation. The polylogarithm function is defined by the infinite sum, or power series. This definition is valid for arbitrary complex order S and for all complex arguments Z with Z1, where Lie, 1, is finite. The relation also holds with m equals 0 or m equals p. While this formula is not as simple as that implied by the more general relation with the Hurwitz zeta function listed under relationship to other functions below, it has the advantage of applying to non-negative integer values of S as well. As usual, the relation may be inverted to express I paragraph, S, mar P, for any m equals 1. P is a Fourier sum of Lie's, exp, 2 I car P over K equals 1. P. Relationship to other functions, for Z equals 1 the polylogarithm reduces to the Riemann zeta function. The polylogarithm is related to Dirichlet eta function and the Dirichlet beta function. Where I, S, is the Dirichlet eta function. For pure imaginary arguments, we have where I squared, S, is the Dirichlet beta function. The polylogarithm is related to the complete Fermi-Dirac integral as the polylogarithm is a special case of the incomplete polylogarithm function. The polylogarithm is a special case of the Lerch transcendent. The polylogarithm is related to the Hurwitz zeta function by which relation, however, is invalidated at positive integer s by poles of the gamma function I, 1as, and at s equals 0 by a pole of both zeta functions. A derivation of this formula is given under series representations below. With a little help from a functional equation for the Hurwitz zeta function, the polylogarithm is consequently also related to that function via which relation holds for 0 per mole currency Re, x, 0 and all z except for z real and a per mole 1 yen. The polylogarithm in this context is sometimes referred to as a Bose integral or a Bose-Einstein integral. Similarly, the polylogarithm can be expressed in terms of the integral of the Fermi-Dirac distribution. This converges for Re, s, 0 and all z except for z real and a per mole currency A1. The polylogarithm in this context is sometimes referred to as a Fermi integral or a Fermi-Dirac integral. These representations are readily verified by Taylor expansion of the integrand with respect to z and unwise integration. 2. A complementary integral representation applies to Re, s, 0, circles the origin without enclosing any of the poles t equals a micron plus 2 key I, and terminates at plus a on the lower half plane.